So now let's take a problem which is based on IC engine and which is asked in year 2004. So now let's take problem get AME 2004. So first of all I am writing the problem. An engine working on air air standard auto cycle has a has a cylinder diameter of 10 centimeter and stroke length of 15 centimeter. The ratio of specific heat the ratio of specific heat for air is 1.4. If the clearance volume if the clearance volume if the clearance volume is 196.3 cc and heat supplied per kg of air per cycle is 1800 kilojoule per kg, then find work output per cycle per kg of air. Now let's solve the problem. So I am solving this problem, and in the problem clearance volume is given. So first I will write the clearance volume VC, that is given 196.3 cubic centimeter, that is given in the problem. Similarly, we can also find out stroke volume. So the stroke volume is nothing but pi by 4 d square L. So in that problem, stroke length is given 15 centimeter and bore dia is given 10 centimeter. So now if you plug this value here, pi by 4 d square means 10 square into 15, so it will come 1178.09 cubic centimeter. So we are having the value of Vc and Vs, so easily we can find out compression ratio. So compression ratio, that is denoted by Rk, equals to 1 plus Vs by Vc. 1 plus Vs by Vc. So 1 plus Vs is 1178.09 and Vc is 196.3. So Rk will be 1 plus, so now 1178.09 divided by 196.3, it will come 6. So Rk will be 1 plus 6, 7. So Rk we will get 7. So now we are having compression ratio, so easily we can find out the efficiency of Otto cycle. So efficiency of Otto cycle is nothing but 1 minus 1 upon Rk to the power gamma minus 1. So 1 minus 1 upon 7 to the power 1.4 minus 1. So now let's calculate this thing. So 7 to the power 1.4 minus 1 is 0.4, and the reciprocal of that, it will come around 0.459. So efficiency of Otto will come 1 minus 0.459, it will come 0.5408. So the efficiency of the Otto cycle is coming 0.5408, but we are interested in work output. So here heat supply per kg of air per cycle is given, means Q1 is given in the problem, that is 1800 kilojoule per kg. So now efficiency of Otto, we can write work output work output divided by Q1. So work output in that case, work output equals to efficiency of Otto into Q1. So 0.5408 multiplied with 1 and 0, 0. So if we calculate this thing, then it will come, if we calculate this thing, will come around 973.5 kilojoule per kg. So the work output will come 973.5 kilojoule per kg. Let's take another problem which is asked in year 2003. So I am writing problem for GATE ME 2003. An automobile engine operates at a fuel air ratio of 0.05, volumetric efficiency of 90%, and indicated thermal efficiency of 30%. Given that the calorific value of the fuel is 45 megajoule per kg, and the density of air at intake is 1 kilogram per meter cube. Find the indicated mean effective pressure. Find indicated mean effective pressure for the engine. Now let's solve this problem. So first of all, I will write all the given data. So given here, fuel air ratio is given. So fuel air ratio, that is given 0.05. Volumetric efficiency is given 90%, that is 0.9. Indicated thermal efficiency is given 30%, that is 0.3. Calorific value is given, that is 45 megajoule per kg, and density of air is given 1 kilogram per meter cube. So here the fuel air ratio, I can also write mass of the fuel divided by mass of the air is given 0.0. So now let's take a formula for volumetric efficiency. So I am writing the formula: volumetric efficiency equals to actual volume divided by swept volume. or we can say that actual volume of mixture. Actual volume of mixture. So here I can write actual volume, actual volume equals to NV into Swift volume. So the actual volume will be zero point 0.9 V. So we are having actual volume 0.9 Vs. Now mass of the air, that is I will write here, mass of air is nothing but density of air into actual volume. Actual volume. So now Ma will get density, that is 1, actual volume is 0.9 Vs. So the mass of the air is 0.9 Vs. The mass of the air is coming 0.9 Vs. We can easily calculate Mf. So Mf, we know Mf by Ma equals to 0.05. So Mf equals to 0.05 into Ma. So Mf equals to 0.05. In place of Ma, I can write 0.9 into Vs. So if we multiply 0.05 into 0.9, we will get, if we multiply 0.05 with 0.9, 0.05 into 0.9, so we will get 0.045. So MF equals to 0.045 Vs. So MF will come 0.045 Vs. Now we are having one more parameter, that is indicated thermal efficiency. So for indicated thermal efficiency, I can write, that is indicated thermal, that is indicated power divided by mass of the fuel into calorific value. So again we will rewrite these things, that is mean effective pressure into LAN divided by MF into Cv. So now indicated thermal efficiency we are having 30%, so 0.3. We have to find out mean effective pressure. This LAN we can write in terms of Vs, and this MF in place of MF, and Cv in place of Cv we are having 45 megajoule per kg, and this MF we are having 0.045 Vs. So MF 0.045 Vs into Cv, I am writing in terms of joule per kg. So 45 megajoule. So 45 into 10 to the power 6. So now PMEP, that is mean effective pressure, will be 0.3 into 0.045 into 45 into 10 to the power 6. So if you calculate this thing, then mean effective pressure will come 6.075 bar. So the mean effective pressure in that problem will come 6.07 bar. 075. Now let's take another problem which is asked in year 2003. So get ME 2003. I am writing the problem here. For an engine operating on air standard auto cycle, the clearance volume is the clearance volume is 10% of the swept volume. The the specific heat ratio of air is 1.4. Find the air standard cycle efficiency. Find the air standard cycle efficiency. So now let's solve this problem. I am solving this problem here. In that problem, it is mentioned that clearance volume is 10% of swept volume. So I can write clearance volume 10% means 0.1 of Vs. So now Vs by Vc is 1 upon zero point 0.1 equals to 10. So now we are having Vs by Vc. So we can easily find out compression ratio with the help of Vs by Vc. So compression ratio that is denoted by Ra equals to 1 plus Vs by Vc. So 1 plus 10 equals to 11. So now we are having the compression ratio that is 11. So air standard efficiency for Otto cycle, I can write 1 minus 1 upon Rk to the power gamma minus 1. So efficiency of Otto equals to 1 minus 1 upon Rk is 11. Gamma that is mentioned 1.4 minus 1. So now 11 to the power 1.4 minus 1, that is 0.4. It is coming 2.6, and if we take reciprocal of it will come 0.383. So the efficiency of Otto equals to 1 minus 0.383. So 1 minus 0.383, it will come 61.7% or 0.617. So in terms of percentage, it will come 61.7%. The efficiency of Otto is coming 0.617, or we can say that 61.7%. Let's take another problem which is asked in year 2001. So get AMI 2001. So I am writing the problem here. In a spark ignition, spark ignition, in a spark ignition engine working on the ideal Otto cycle, the the compression ratio is 5.5. The work output per cycle, that is area of PV diagram. The work output per cycle is equal to 23.625 into 10 to the power 5 Vc joule, where Vc is clearance volume in meter cube. Find the indicated mean effective ratio. Indicated mean effective ratio. Now let's solve this problem. The compression ratio is mentioned, that is 5.5. Rk equals to 5.5 is mentioned. So Rk we can write, it is nothing but V by Vc. So we can say that that is V by Vc. So it is 5.5. So Rk is V by Vc, that is 5.5, and here V is nothing but summation of clearance plus surface volume. So I am having the work output also here. This work output is 23.625 into 10 to the power 5 Vc. That is our work output. So work output I can write in terms of mean effective pressure and difference of total volume minus clearance volume. So work output is 23.625 into 10 to the power 5 Vc and Pm. So I have to write V minus Vc. So we know V by Vc is 5.5. So V will be 5.5 of Vc. So 23.625 into 10 to the power 5 Vc equals to Pm. V is 5.5 Vc minus Vc. So Pm will be 23.625 into 10 to the power 5 divided by 4.5. So it will come 5.25 into 10 to the power 5 Pascal. So in terms of bar, we can write 5.25 bar. So the mean effective pressure in bar is 5.25 bar. Now let's take another problem which is asked in year 1999. So get AMI 1999. So I am writing the problem here. The silencer of an internal combustion engine, internal combustion engine. A, the options are A, reduces noise. B, decreases brake specific fuel consumption. That is brake specific fuel consumption. C, increases brake specific fuel consumption. And D, has no effect on its efficiency. It's again a straightforward question. We know the silencer in an internal combustion engine, it will not affect the brake specific fuel consumption, but it reduces the noise. So the correct option is A. The silencer of an internal combustion engine will reduces noise. Let's take another problem which is asked in year 2003. So I am taking the problem, get AMI 2003. I am writing the problem. A diesel engine is usually more efficient than a spark ignition engine, because A, diesel being Diesel being a heavier hydrocarbon releases more heat per kg, releases more heat per kg than gasoline. Than gasoline. Option B, the air standard efficiency, the air standard efficiency of of diesel cycle is higher than the Otto cycle, is higher than the Otto cycle at a fixed compression ratio. At a fixed compression ratio. C option, the compression ratio of a of a diesel engine is higher than is higher than that of an SI engine. And the option D, self ignition temperature of diesel is is higher than that of gasoline. So this question is again a straightforward question, and we have already discussed in the theory. In diesel engine we will go for high compression ratio, and due to this high compression ratio it is more efficient than a spark ignition engine. So the correct answer is C. The compression ratio of a diesel engine is higher than that of an SI engine. So it was all about IC engine, and we have already covered all the theory and as well as the numerical examples. So now I think you will be quite comfortable with IC engine and all other topics regarding thermodynamics. Thank you.